Hello guys, my name is Pino, and in this video we'll be going through from the April 6, 2021 N4 Mathematics question paper. Question 3.1, we have to differentiate y is equal to the square root of sec x using the chain rule or the function of the function. So y is equal to the square root of sec x. For simplicity's sake, we write this as sec x to the power 1 over 2. So dy over dx will be equals to 1 over 2 into sec x 1 over 2 minus 1. Now that we have differentiated the parentheses, we also have to differentiate the inner function. So the derivative of sec x is equals to sec x tan x. It's also available on our formula sheet. One over 2 minus 1 is equals to negative 1 over 2 multiplied by sec x multiplied by tan x. So this is divided by 1. This whole thing is divided by 1. So we are taking the numerator to be the denominator. So this whole thing is going to change from negative 1 over 2 to positive 1 over 2 multiplied by sec x tan x so sec x to the power 1 over 2 is just the same as the square root of sec x multiplied by the sec x tan x. So 1 multiplied by 1 is equals to 1, and 1 multiplied by sec x tan x is equals to sec x tan x. The denominator 2 multiplied by the denominator, the square root of sec x is equals to 2. The square root of sec x, and we have this as our answer for question 3. Question 3.2, we have to differentiate the following expression. Y is equals to 2 cos 1 divided by cos x plus e to the power 7x all divided by 14 minus 2 to the power x plus pi to the power 3x all divided by 4 minus 2b plus 1 over 2 in x. Before we can proceed, let's take the sin 2x plus 1 over cos x and let's simplify it. So sin 2x, according to our formula sheet, according to this formula sheet, sin 2x will be equals to 2 sin x cos x plus 1 over cos x, because x will be equals to a will be equals to x and b will be equals to x. So we'll have x there, x there, and we will have 2. We will have sin x cos x plus sin x cos x, which will be 2 sin x cos x. And from here, if we had a plus b over c, this is equals to a over c plus b over c. So this will be equals to 2 sin x cos x over cos x plus 1 over cos x. So in the place of this sin 2x plus 1 over cos x, so this is not complete. The cos x will cancel out with that cos x, and we'll have 2 sin x plus 1 over cos x. 1 over cos x is equals to sec x. So in the place of sin 2x plus 1 over cos x, we will substitute 2 sin x plus sec x. Plus e to the power 7x over 14 minus 2 to the power x plus pi to the power 3x over 4 minus 2b plus 1 over 2 ln x. So from here, so if we had y is equals to e to the power x, so the derivative of this, when we differentiate y is equals to e to the power x, we get ln e multiplied by e to the power x. But ln e is equals to 1. So the derivative will just be equals to e to the power x. So if we had 1, y is equals to a to the power x, this will be, so when we differentiate this with respect to x, this will be equals to ln of a multiplied by a to the power x. So we have to differentiate that. So dy over dx will be equals to 2 times the derivative of sine x, which is cos x, plus the derivative of sec x. From our formula sheet, it's sec x tan x plus the derivative of e to the power 7x will be equals to e to the power 7x over 14. But according to the chain rule, we also have to differentiate the exponent 7x. So the derivative of 7x is equals to 7 minus ln of 2 multiplied by 2 to the power x. And we also have to differentiate the exponent x. So when we differentiate the exponent x, we get 1 plus ln of pi multiplied by pi to the power 3x multiplied by the derivative of the 3x. So the derivative of the 3x is equals to 3, but this is divided by 4. The derivative of this negative 2b, so this negative 2b is not attached to any x, so we treat it as a constant. So the derivative will be equals to 0 minus 0 plus 1 over 2 multiplied by the derivative of ln x, which is equals to 1 over x. So our dy over dx is equals to 2 cos x plus sec x tan x plus e to the power 7 x. 7 divided by 14 is equals to 1 over 2 minus ln of 2 multiplied by 2 to the power x plus 3 over 4, the 3 ln pi multiplied by pi to the power 3x plus 1 over 2x. So this is our answer for question 3.2. Question 3.3, you guys will be using first principle to differentiate y is equals to 5 multiplied by x to the power 5 minus 2x. And question 3.4, we are given the function y is equals to x to the power 3 minus 12x squared plus 16x minus 12. We have to determine the coordinates of the points of inflection using the second derivative. So to determine the coordinates of the points of inflection, we have to differentiate y with respect to x the first time, and also differentiate y with respect to x for the second time, and we equate it to 0. So the first derivative, so we differentiate y with respect to x for the first time. The derivative of x cubed is 3x squared, and the derivative of negative 12x squared is equals to negative 24x, and the derivative of 16x is equals to 16, and the derivative of negative 12, because it's not attached to any x, will be equals to 0. So the negative 12 is our constant. So we have to look for the second derivative. The derivative of 3x squared is equals to 6x and the derivative of negative 24x is equal to negative 24. And since the 16 is not attached to any x, we treat it as a constant, so the derivative of the 16 will be equal to 0. And like I said, to determine the point of inflection, the x coordinate of the point of inflection, we have to equate this to 0. So you have 16x minus 24 is equal to 0. We take the 24 to the left, to the right, it's going to change sign from negative to positive 24. And in order for us to find the x coordinate of the point of inflection, we have to divide by 6. So x will be equal to 24 over 6, which is equal to 4. So we managed to get the x coordinate of the point of inflection. So we are left with the y coordinate. And to determine the y coordinate, we have to take this x and substitute it back to the original y equation. So where there is x, we substitute 4. This is equal to negative 76. So the coordinate of the point of inflection and negative 76.